Okay, welcome to day 4. Hopefully you're still doing well. It'd be great to hear from you, so maybe just send me a quick email and just let me know how things are going. Even if it's like everything's sweet, or if you've got any other things you want me to do, let me know. It'd be good to get some feedback from you all. So question 7 at this stage is the highest ranked one, actually part 2 is, but I'm going to do part 1 as well, because for me it's easier to do both parts and get my head around it at the same time. Cool, so part 1, nobody voted for this one, which is awesome, because it should be that way, because it is just the perpendicular bisector of AB. So let's just do that really quickly. So we need to know what the midpoint is between those 2 points, so between -1 and 6 and 7 and 2, and so the midpoint for that one is going to be halfway. So it's going to be the point 3 and the point 4. We also need to know the gradient of the original line so that we can find the gradient of the perpendicular. So that's going to be 2 minus 6 all over 7 minus -1. So what's that? -4 over 8. So -1/2. And then for the perpendicular gradient, obviously we're just going to flip that upside down and change the sign. So that's 2. Then to put that into the equation of the line is m times x minus x1, which equals y minus y1. So we whack that in there. So 2 is the gradient for the perpendicular line. You can choose either point you want. Oh, sorry. You can't choose either point you want. You're choosing the midpoint. So we're going to put in 3 for x, and we're going to put in 4 for y. And then just for this question, because they've specifically asked for it to be in y equals mx plus c form, we just have to do a little bit of rearranging, and then what we should get is y equals 2x minus 2. Okay, so on to part 2, which is the one that you guys actually voted for. So I'll try and take this one a little bit more slowly. So we know that this point C is on this perpendicular bisector that we just found before. So the perpendicular bisector we found before was y equals 2x minus 2. What I'm going to do, as you know, I like my diagrams, is I'm going to draw myself really quickly a sketch of it. So if it's y equals 2x minus 2, then I know it goes through -2 on the y-axis, and it's got a gradient of 2. So it's going to cut there at 1, and at 2 it's going to be here at 2. And I'm going to sketch that out for myself as my line. So that is the perpendicular bisector. Cool. And then it's saying here that there's this particular point, PQ, that's on somewhere on this line. I'm going to just make up a point. So I'm going to make up a point there, and I'm going to call that PQ. Now this is not necessarily where that point is, it's just to help me see it visually. And what I know is that from the origin to that point is a distance of 2. That's what they've told me. And what I've got to do is find the possible coordinates for C. And what you should be able to see when you look at this diagram is I've put PQ there kind of like above the x-axis, but let's say I put PQ down here, then that also could be a way of getting the distance between O and C, which is this point, as being 2. So it looks to me like there could be a couple of solutions. In fact, if we're actually super sneaky, we can see one of the solutions straight away, which is that is one solution there, because if this line goes through the y-axis at -2, the distance from the origin down to there is going to be 2. But I suspect we have to use actual algebra to show what those 2 possible solutions are for P and Q. Okay, so what we've got to do is we've got to set up some equations in terms of P and Q. The first obvious one to start off with is the fact that it's on this line, which is the perpendicular bisector. So when x is P, when we substitute in, we'll get y is Q. That's the first place to start. So Q is the same as 2P minus 2. Then what we need is another way to express P and Q as a relationship, so that we've got 2 equations with 2 unknowns that we can solve simultaneously. But fortunately for us, we're getting super, super awesomely clever at using right angle triangles to help us solve stuff. So if I take this point here, let's say it's sitting here, we know that the length from 0 to that point is 2. At the same time, we know that that point is P that way and is Q that way. So we get a triangle like that. Like this, which is across by P and up by Q, and we know the distance is 2. As an equation, that's going to look like this. So P squared, plus Q squared equals 2 squared, which is 4. Okay, so now we've got two equations with two unknowns, and what we've got to do is put them into one equation that's either only in P or only in Q. So you should be not surprised to find out that that's going to be a quadratic. So what I could do is substitute that Q there with all of 2P minus 2. So if I set that up here, like so, then, oopsies, it's not. It's an equal sign, not a plus. Then all that is involved now is a bit of algebra. And of course, we're going to look at this one here and be like, 2p minus 2 all squared involves us multiplying 2p minus 2 times 2p minus 2. That's going to give us 3 terms when we simplify it. Don't forget to expand that properly. So that's going to give me 4p squared minus 8p plus 4 equals 4. And when I rearrange that and kind of group things together, I get 5p squared minus 8p equals 0. And when I solve this, I'm going to take p out as a common factor, and I'm going to get 5p minus 8 equals 0. So when I solve that, I'm going to look at equating p to 0 and then equating 5p minus 8 to 0. So obviously one of my solutions is going to be 0 for p, and the other solution is going to be negative 8 over 5. Okay, so those are my two possible solutions for p. What I need to be careful about actually is that I want to give the two coordinates like that, so making it clear which one goes with which. So 0 and 8/5 are my two possible p values. And to get my two possible q values, I'm just going to substitute that in. So I can choose this equation here is the easiest one to use. So when p is 0, I put it in there, then q is going to come out to be negative 2. And when p is 8/5, if I put it in there, then q is going to come out to be 6/5.